So before I go further, I think I should explain to you how do we get the probability. Because this probability analysis with the data that we have is very important to fulfill our promise to the customer. Okay, so let's refresh, and this kind of refreshment for your statistic lesson. For example, this data set. We have frequency here, frequency, and birth weight. So we want to know, maybe if we have a lot of data, we want to know what is the probability that the baby born less than 2,000 gram, maybe. So we want to know that. Brain size for 40 students, and it is normally distributed. We have data for frequency versus our independent variable, serum level for healthy patient, and so on. We consider binomial and Poisson distribution. We saw that probability distribution were characterized by formula for the probability for each possible discrete value. So all probabilities is equal to 1. For example, coin, we have parliament and the number. The probability of, when we toss the coin, the probability of getting the number is 0.5. Why 0.5? Because the coin has two faces. That two faces is equal to 1. So half of two faces is 1. So 1 over 5 is 0.5. So the total probability is 1. When we have a cube, the face of the cube is 1, 2, 3, 4, 5, 6. 6. So when we throw the cube, the probability for that cube to face to the top is 1 over 6. Because the total face is 6. Total face is 6, equivalent to 1 probability. So the probability of when we throw the cube, when the cube lays on the table on the floor, the face that facing to the sky or to the ceiling is 1 over 6. So total probability is 1. And it is demonstrated in this probability distribution. The area underneath this curve is equal to 1, the area. And this is continuous probability distribution. When we have a lot of data, the probability, which is the area underneath this curve, is equal to 1. And from here, we know the mean is equal to 100. Mean is equal to 100. And the probability is the area underneath this curve is equal to 1. In the normal distribution, as I show here, the 100, this 100 is a mean because it's what we call it, is in line with the peak 100. And another one is the standard distribution, the standard deviation or dispersion of this distribution. Remember, the purpose of quality improvement is to reduce variation. What does it mean? Okay. This is normal distribution. This is mean. The area here is equal to 1. Probability is equal to 1. The entire area. And the variation, that is a deviation. The deviation or related to the variation that is related to the standard deviation. So our purpose to minimize the variation is to squeeze this. So when we squeeze this, the peak will increase. The peak will increase. That's our purpose. Okay. So from the plot, from the curve, we can see the mean and the standard deviation. This is a review only.
Prof, one question. When you say to increase the peak, is mean up to the, I mean, we climb out like the table's density on the right hand side.
Yes.
So it means that we need what, continuous data or?
Data should be continuous. Yeah, we need a continuous data. So when we reduce the variation, the density will increase. Okay, look to this normal distribution. As you see here, left-hand side and right-hand side, the means is equal, 100 and 100. But what happened when we reduce the standard deviation at the right-hand side? Although the mean is the same, when we reduce the variation, the peak is increased, means the density is increased.
So it means that the data is a very good data. It's not rough data.
Statistician assume when we have lot of data, the data is normal. But in the real practice, the data is not necessarily normal. Okay, we make comparison with this one. Mean 130, standard deviation 10. So this one, on the right-hand side, the means is changed to 100, standard deviation reduced to 15. Can you see the difference? So when we increase the standard deviation, the curve become fat, and the density reduce. This one, higher density because of standard deviation is less. So I hope you understand the purpose of quality improvement is to reduce variation. So when we reduce the variation, of course, standard deviation reduce, the density will increase. So this is how we write in a mathematical way. When we want to say X is normally distributed, normally X normally distributed with mean and standard deviation squared. That's how we write. N means that normally distributed. And sigma here is the standard deviation. But in this expression, we write as variance, sigma squared. Although we have this formula to calculate the probability density, but we don't have time to calculate this. So we use table instead. So we don't want to calculate this manually. We use table. Suppose for this one, our mean is equal to 0. In order to use the table, there is a Z table here, mean must be equal to 0. Then we can use this table. Mean equal to 0 here. Then 1 here, positive. We want to know what is the probability it is less than 1. We use this table. 1. When we have this kind of table, positive on the left-hand side here, means this table, we read from the left to right. We read from left to right. So to get this area, the hash area, 1, if it is 1, is 0.8413. So means the area for this hash is 0.8413. How about this one? Definitely, as I mentioned before, the total area underneath this curve is equal to 1 because the total probability is 1. So half of this is equal to 0.5. 0.5. So the area for this is 0.5. So this case, when we have mean equal to 0, this one, mean equal to 0, and standard deviation equal to 1, or variance equal to 1, like this, this is what we call standard normal distribution. The distribution is normal when we have mean equal to 0, variance equal to 1. Then we can use this table. So if we don't have this, if we don't have 0, 1, we cannot use that table. So what should we do? We have to normalize. We have to do the normalization to make it 0 and 1. Before I show you how to do the normalize, let's familiar with this table first. Suppose if you want to know the area, this hash area that less than z, we just simply read from this table. This is example 1. If it is normally distributed with mean 0 and variance 1, what is the probability z greater than 0.92? This is 0.92, greater than 2. As I mentioned earlier, this table, positive table, we read from left to right. Left to right. So left to right, if I can jot down here, here is 0 because this table is 0, 1. So I mentioned read from left to right. Left to right, 0.292. We want to find out this area. So 0.92, look at to the table, 0.9. Can you see my cursor? Okay, good. 0.9, 2, 0.8212. (0.8292). The probability z less than 0.92. What does it mean? It is less than 0.92. The probability is 82.12%. This is the answer. So what is the probability? It is more than 0.92. It is 1 minus 0.8212. Why 1 minus? Because the total area is equal to 1. So the question here, they want to know greater than 0.92. So that's what I did. 1 minus. So I got 17.8%. So is the probability here is 17.88%. The customer might ask you, what is the probability I will get my stuff after this? So the answer is 70.88%. This is when we have normal distribution with mean 0 and variation 1. So later I will show you how to do the standardization when we have the real case. We just go through this example first before we go to the real case. This one, when we have normal distribution 0, 1, we want to know the probability. It is greater than minus 0.5. Greater than minus 0.5. Okay. Minus 0.5 is here. Greater than here. Okay. 0. The question wants to know greater than 0, minus 0.5, right? Greater than. Yeah. We want to know this area. So the total area is 1. I don't want to make you confused. Actually, I can read from another table, minus table, so it straight away give me the answer. But let's standardize this because I think you have been too long leaving your school, so I don't want to make you confused. So 0.5, how to get this? 0.5. So we flip this. We flip this curve. So we flip this curve, become like this. We flip. So 0.5 is here. So we read from the table. 0.5 from this table. 0.5 is 0.615. So 0.615 is the same with this one. So the answer is 0.615. Because we flip this curve. We flip this curve. Example 3, what is the probability less than 0.76, less than, previous one, greater than. We flip, then we can read from the table 0.5, probability 0.5. But this one, we want to know less than 0.6, not more than. You want to know at here. So what should we do is, we flip. Then we read this area. This area is 0.76, 0.7764. 0.76 here, 0.7764. So this area is equal to 1 minus 0.7764 equal to 2236. And this is the answer for this. Same answer. Okay, understand? And how about this? The approach is still the same. First, we find out if it is more than 0.64. We flip this one, and then we use the same like we did. Wait, sorry. We use like we did in example 3. We do one by one. Then we got 0.4053. This is when we can get everything in the table. But example 5, when we have to do the interpolation, in this example shows you when we have two values, we interpolate between two values. But this is manual interpolation. You can read by your own, or maybe you can use calculator to do the interpolation. I think you are familiar with this during your undergraduate. But what I want to show now, in the real world, we couldn't get mean equal to 0, standard deviation equal to 1, or variance equal to 1. We should have the mean value. We should have the value for variations. But the table that provided to us is not mean equal to something. Mean is equal to 0. The table is mean equal to 0, variance equal to 1. So in order to accommodate that, we have to do the standardization. How to do the standardization? Suppose we have this mean 3, variance 4, means standard deviation equal to 2. Remember, standard deviation is square root of mean. Square root of variation. Variation 4, standard deviation is equal to 2. The question is, what is the probability it is less than 6.2. So I hope when I explain this, you can relate to your actual case. If you have data, you have your mean, you have your standard deviation that you calculate from your data. Then you want to do the probability test because you want to set your KPI, or maybe you want to set your promise to customer. The patient at the emergency department in hospital will get treatment and then we will return home or sent to the ward before 4 hours. So what is the probability? It is more than 4 hours. We want to know that. Before we decide, we should calculate the probability. So when I explain this, I hope you can relate in your mind with the real scenario. Okay, this is our mean, this is our variation. Okay, this is the mean here, to the top, to the peak here, and then your variation is 4 equal to standard deviation 2, and you want to know whether it is less than 6.2. So first step to do the standardization. First step to do the standardization, because we want to make this one mean equal to 0. First step, we shift the mean. So how to shift the mean? Just now, mean is 3, right? 3, 4. So 3, 4, this is the, sorry. This is the sigma squared, this is the mean. So first step, we shift the mean. Means 3 minus 3 equal to 0. So this is 0. And we want what? We want to know 6.2. This is 6.2. So this point, 6.2, because everything moved by the mean, 3 minus 3. Then you divide by standard deviation is equal to 2. Equal to 3 over 2. Sorry for the bad drawing. So if you look at here, it is 4, 6.2, 3, 3.2. Sorry. 6.2. So the answer is 6.2 minus 3. 3.2. 0.2. Then we divide by 2 equal to 1.6. So the final one that we get is 1.6. Like this, 1.6. Then when we have this, we can read from the table. We want to know this area. So the probability less than 1.6. We go back to the table. 1.6. This table is not enough. So we read in the actual table, the full table. I do have the table here. So I open up another file. 1.6. Huh? This is the table, Z table. Okay, 1.6. 1.6. 0.9452. 0.9452. 0.6. So the probability of Z less than 1.6 is equal to 1.9452. So what is the probability it is more than 1.6? 1 minus 0.9452. So if you look at this table, this is the full table that I used just now. It is based on the area from left on the left hand side. But this one, the negative one. So as I mentioned before, when you have negative, you can straight away read from this. But I don't want to make you confused. That's why I used that approach before. So I just use this table. I don't want to make you confused. So if we compare that answer, (9452). So the answer is correct. And this is the step to do the standardization. Sigma is standard deviation. So we zeroize the mean like we did just now. This is another example. Suppose we know that the birth weight of babies is normally distributed with mean 3,500 gram, standard deviation 500 gram. What is the probability that a baby is born less than 3,100? So this is the mean and standard deviation squared, variance. What is the probability? Less than 3,100. So 3,500, 500. 35. Wait. 3,500 and what was that? 500 squared. (500 squared). That is the variance. So initially 3,500 like this. So (3,500) minus 3,500, 0. We want to know less than 3,100. Sorry. Less than 3,100. Yeah, 3,100. You want to know less than this. That's what we want to know. So how to deal with this? 3,100 minus 3,500 divided by standard deviation. The standard deviation is 500 equal to minus 0.8. So if we can draw back 0 minus 0.8. So we want to find here 0.8 minus 0.8 minus 0.8. Either we can use this one straight away, minus 0.8, 0.2119 or we read from this table but we need to flip them. We flip like we did before. We flip, sorry. We flip so we measure the area here is 0.8, 0.7881. So the area here is 1 minus 0. The answer is the same. So that is the probability this baby born with less than 3,100 gram. We calculate with this approach, with this method. We got the answer 0.2119. So it is 21.19%. So that's all for